Hello everyone, and today in this video we will be deriving the radius of Bohr orbit expressions. So radius of Bohr orbit. First of all, let us consider a proton here and an electron is revolving around it, and by this model you know that this is of the hydrogen atom. Let the radius of the orbit be r, and when the electron is here, its velocity be v, and the electrostatic force is providing at the centripetal force, that is F centripetal is equals to mv square by r equals to k z e square by r square. As we know, this is hydrogen atom, so we will take z equals to 1. mv square by r will be equals to ke square by r square. Now we will use Bohr's first postulate by Bohr's first postulate, which we call as quantization of momentum. mvr equals to nh upon 2 pi. From here we can replace the value of v, which is equals to nh upon 2 pi mr, and now we will put it in the above equation and we get mn square h square divided by 4 pi square m square r equals to kze square by r square. Here r square will be cancelled out, m will be also cancelled out here, and we are getting finally, on arranging this equation, r equals to n square h square divided by k z square 4 pi square m, and we know k can be also written as 1 upon 4 pi epsilon naught. So on putting this value here, r will come out to be epsilon naught n square h square divided by pi e square m. So this is the value of r, and on putting all the values of such constants here, we are getting r in ground state equals to 0.529 angstrom, that is say r naught. This formula can also be written as r equals to r naught n square equals to 0.529 n square angstrom. One of the important formulas. Now to calculate the velocity, we will substitute this value of r, or you can say rn, in the formula v equals to nh upon 2 pi mr. We will get vn equals to ze square divided by 2 epsilon naught nh. If again z is 1, then vn will be e square by 2 epsilon naught nh. Well, the most important formula is this radius. Now let us do some analysis on this expression. When this one is r1, what will be the value? 0.529, that is ground state. In r2, what this will be? It will be 0.529 multiplied by n square, that is 4. Then in r3, it will be 0.529 multiplied by 3 square, that is 9, and so on. So here you can see, if I take the ratio of these, r1 ratio 2 ratio 4, sorry, it is r3. So I am getting here 1 ratio, 4 ratio, 9, and if there will be so-called R4, then there will be 16. If R5, then this will be 25. So in this case, you can see the ratios are just squaring with the orbital number. The orbit number is just squared here. Is just squared. Okay. So this is the expression for the radius of Bohr orbit.